Welcome back. Now, as we've seen in the previous video, we're now able to shoot at the enemy drone, but we can't really see what we're shooting at. The mesh is in the way. And in addition to not being able to see what we're shooting at, it'd be nice to have some crosshairs, some kind of visual element that we can see exactly where we're aiming. Crosshairs are great for shooting games, and our collision tests project from the last section actually has some crosshairs. So we're going to get those into our project. So let's open collision tests. In the content drawer, we can go to assets and textures.
That's fucking annoying. I just had this open, making me open it all over again. Gotta open up collision tests.
We have one central dot. We can see by opening it up. Here's our texture. And then we have the different arms from the bottom.
Oh my god, there's so many.
So we're going to get these over into our project. We can do that by simply taking the textures folder and migrating it. So I'm going to right click on it, migrate, click OK, and get this into my content folder. Select that folder, and I'm done with collision tests. And now in my assets folder and textures, I have the crosshairs. And if I open them up, I can see what they look like. And we want all of these to be on the screen. Now, to put things on the screen, we have to use a special kind of blueprint called a widget blueprint. Widgets are HUD elements. HUD stands for heads up display, and this is things that we see on the screen in video games. They're in all games, things like progress bars, crosshairs, and what have you. So we need a widget blueprint where we can decide what to show on the screen. So to do that, I'm going to go to my blueprints folder, right click, make a new folder called UI for user interface. And in this folder, I'm going to make a new widget blueprint. I can do that by right clicking, scrolling down to user interface, and choosing widget blueprint. Now, when I create a widget blueprint, I choose a parent class. And the user widget is the class that we're going to derive from when we create widget blueprints. So I'm going to select user widget and call this WBP, short for widget blueprint, overlay HUD. And this will be the HUD that we see on the screen when we're playing the game. And this will have a crosshairs on it. So let's double click to open this up. And this looks a little different than an actor blueprint. It has a designer tab and a graph tab. The designer tab is where we design the widget blueprint visually, and the graph tab is where we can implement functionality. See, we have an event graph with nodes, much like the event graph in an actor blueprint. But we're interested in the designer tab, and what we want is the ability to drag images into our widget blueprint. Now we can drag images in. We have a lot of different types of widgets in the palette panel. One of those is image, and if we drag that straight onto our event graph, well, we have this image. It's the size of the screen, and it doesn't have any specific texture selected for it, so it's just a white image. Image widgets have what's called a brush, and a brush is a structure that has a number of properties, including a texture called image. Now, if we select this image and open the image dropdown, we can choose one of these textures that we have for our crosshairs, such as the center. Now, this texture is now stretched across the entire viewport, and that's not exactly what I want to see. In addition to that, I want to drag multiple images on top of each other. And I can't do that either. If I drag another image in, it'll show me that I can't just release and get another one. If I want multiple images stacked on top of each other, I have to use a type of widget called an overlay. Now we can search the palette for different types of widgets. We can find overlay and we can bring it in. Notice we have a hierarchy panel that shows us the widgets we have in our widget blueprint. But if we bring an overlay in, it's not going to let us simply drag it and drop it, because an image is not capable of having things stacked on top of it. It's the overlay widget that allows other things to stack on top of it. So we have to
Delete our image. Yep.
and bring in our overlay first.
Saw that coming.
Now that we have an overlay, we can start bringing in images on top of the overlay. And notice that those images are no longer stretched. In fact, we can take that image, select it in the hierarchy, or select it in the designer graph, and we can specify whether we want it to stretch or not. We can do that under padding, where we see horizontal and vertical alignment. There are options to stretch it, or there are options to center it, or align it to the left, right, bottom, or top. We want center aligned both horizontally and vertically. And we can also go into our brush, into the image, and select one of our crosshair textures. I'm going to select crosshair center, and there it is, a tiny little dot. And it's right here in the center of the screen. And we can rename images in our hierarchy, and notice that they are attached to one another in a hierarchy. I'm going to rename this image to image underscore crosshair underscore center, and I'm going to drag in 4 more images. And as I drag them in, I'm going to drag them onto the overlay itself. I'm going to click on it and rename it to image crosshair left, and change its image to crosshair left. Now it's all the way up at the top left by default, but again, under padding, I can set horizontal and vertical alignment to center, and now I have it right there in the middle. I'm going to do this for the 3 other widgets, and it shouldn't take long. All I need to do is drag in the image, rename it to image crosshair right, find the image crosshair right, set it to center, and there it is. Our next one, we'll drag it in, rename it to image crosshair top, set its image to crosshair top, set it to center, and one last image, renaming it to image crosshair bottom, setting its image to crosshair bottom, and making it centered. And there it is. Now, yes, this would be much easier with one single texture. That's true. But I'm using this from another project that had it as separate textures. And if you want to get fancy, you can animate these and make them shrink or expand. But for now, this will work. We now have an image. All we need to do is add it to our viewport. Now, which class we use to do this? Well, that depends on our project and our preferences. You can do it in the player controller class if you have a custom player controller. There's even a class designated for heads-up display called HUD, automatically spawned in your project. But for our project, we're going to keep it simple and just spawn it for now in our bot pawn on begin play. So in our bot pawn
Easy.
on begin play, we're going to create an instance of our WBP overlay HUD. To do that, we have to use a special node called create widget. If we call create widgets, it's kind of like spawn actor from class, only it's specifically for widgets. And we can select the widget class from the drop-down. We're going to choose WBP overlay HUD. We're going to go ahead and hook that up. Now we can use an owning player, which is a player controller object reference. We're going to leave that blank for now, and we've now created a widget. But that's not enough. If we press play, we can't see it anywhere. That's because we have to add it to the viewport after we've created it. To do that, we take the return value, which has the type WBP overlay HUD object reference, and we call a function inherited from user widget called add to viewport. As soon as we do that, our widget will be added to the viewport, and we can press play, and we can see our crosshairs there. Now we still have a problem. Our mesh is right there in the center. Our crosshairs are in the middle, which is great, but our mesh is sort of in the way. Right? So the last thing we're going to do in this video is move that mesh out of the way just a bit. Before we do that, let's give this a comment that says add overlay HUD to viewport. We'll give it a color and show bubble when zoomed out.
Excuse me.
And finally, let's move that mesh out of the way. Now, we don't have to move the mesh itself. What we can move is the camera. And instead of giving the camera an offset from the spring arm, that's not what I want. A better solution is to select the spring arm component, and in the
I did
details
that
panel,
already.
finding a property called socket offset. We
did
can
that.
change the socket offset, and this allows us to move our camera but still be attached to the spring arm without a location offset. So if I take that third parameter of the socket offset vector and set it to about 45, now the camera will be raised a little bit, and we can press play, and we can see those crosshairs just above the mesh. And now it's a lot easier to shoot. Now there is a slight annoyance, and that's that our blaster beams are not always hitting exactly what we're aiming at. It's kind of hard to play test with the BP bot shooting at us. So in the BP bot event graph, I'm going to find fire blaster beam and just disconnect that node for now so it's no longer firing at us. Now I can play test without getting shot. And now if I shoot my blaster beams, notice that they're going straight forward, and my mesh is not exactly aligned with my crosshairs anymore. So I'm not going to hit what I'm firing at. I have to overshoot a bit if I want to hit that bot. So how can we have the best of both worlds, where our crosshair is not being blocked by our mesh and we can see what we're shooting at, but also make sure our blaster beams hit precisely what our crosshairs are aiming at?
Let's get a line trace.
We're going to do exactly that in the next video.
All right.
I'll see you soon.
Oh boy, this is like a 24-minute session.
back.
This is gonna take a
So our
while.
shooting mechanics are looking pretty good, but
I'm gonna put on another pot of coffee here. I gotta ready myself. All right. One of the mysteries. If I grind my coffee too much, does it make my coffee thick? Okay. Getting the right coffee being grind. Yeah, I think I've definitely been over grinding my coffee. That's for sure. Fine granulated sugar. Table salt. I want beach sand. God damn. Oh damn. No wonder. Yeah, I'm like it's just so black. It looks thick and chalky, and I was like, I think I'm grinding. I've only been making coffee for 3 weeks for the girlfriend in the morning. So, during it all. Yes, Gordon Ramsay, I do want to take your master class, but I can't right now. It's not how this works. Okay, this line chase mojo is gonna be fucking fat. I kinda think I need to start a side project. Like, I think I just need to start working on a little something on the side. Just something that I can come back to every day and add a little bit more to, and add a little bit more to. Oh, I like this. We got a striker here with a little turret on the top. Light little Jeep. There's some decent free assets in here for military vehicles. We'll pick up improvised fighter truck here. It's pretty cool. Drivable striker ICV. Oh, this thing's pretty low. Okay. I'll take that. I'll take that. Oh, it's a team of turret gun camera based on camera rotation. Yeah, it'd be cool to make this thing drivable and then rotate the gun and have it shoot at the closest objects until it's dead. I gotta finish this bot tutorial and then maybe I'll start messing with this. Because there's a lot of functions from the bot tutorial. Like I would want to spawn pawns to come at the vehicle. I would want the vehicle to auto shoot at them if it's within a certain range, which I guess I could just do if the vector length from the vehicle to any of these then makes it a target. But I don't know how to spawn a bunch of these and have it automatically pick the closest one. I'm going to have it analyze all targets. And if it's under a certain range, then shoot at the closest one. This is going to be interesting because that's stuff that I don't really know yet. But that's okay. Okay. Kind of want to mess around right now. Shitty thing is, you know what I could do? I could just open up a new project here. Okay. Oh, it's going to take its sweet ass time loading up all those shaders that I don't need for some reason. I don't even know what shaders it's fucking loading at this point. It's a blank project. Unreal? Oh, okay, okay. My browser's out of date. I'm on Chrome. You're fucking out of date. Are you kidding me? I can't use Fab? This is the Unreal Engine built-in browser. This has nothing to do with me. You're fucking stupid. Fucking... You are legitimately the worst. Alright. Let's use the shared textures. It's fine. It's just a road, but it's fucking... It's all bricked up. Here we go. We want asphalt. Let's download 4K asphalt. Ugh, I'm in the wrong fucking one. Of course I am. Empty level. Not a single fucking thing in here. Okay, let's make a basic shape. Cube. Let's stretch the shit out of it. I don't actually know how big that is. Looks good to me, right? Let's add sky. Let's add a skylight. Let's add a atmosphere. Another skylight. Let's go up in their intensity a little bit. Okay, no, never mind. Volumetric cloud. Perfect. An 8x8. I think that looks plenty good. You know what? We're gonna get rid of this. We're gonna make okay. Damn, I gotta go extend my trial. Keyframe frequency of 4 seconds or left. Okay, that's okay. Do I have to exit and restart this to get... to get my trial extension for Dash? Hey? Okay, well, you know what? For my top-down driving test, we can leave it for now. Let's just get... Oh, I don't have any plugins enabled on this either. Dash, okay. Let's get Ludus. Restart. We want snapping helper. An actor locker. Oh no, it's one. Yeah, it's one click. One click materials. We want electric nodes. We want FPS on startup. To-do logging. And we want the collections helper. Okay. Restart now. Okay. Oh. Oh, right. Let's go to project settings. Maps and modes. We want... Let's see if Dash is going to work for me now. MatthewDirex@gmail.com. Oh, come on. My license has expired. God damn it. You're killing me, dog. Killing me. I wonder if I just need to restart all of Unreal. Well, I'm not gonna worry about it for now. Let's just nice. Ooh, my. Oh my goodness. Look at the tiling on this thing. Static mesh component. Let's open this up. So this is great. You know, I've got a player start and I got a fucking mesh, but why do I feel so fucking lost? Oh, you know what? If I get the vehicle in, and I attach a spring arm, then I attach a camera to it, and I make that camera the pawn, I believe. Okay, I'm just gonna save this for now. I gotta finish my tutorial. Because in here, my BP bot is a player start. Pawn. There. Just check my project settings. BP bot Game mode. Default pawn classes, BP bot pawn. Yeah, okay. Yeah. That's great. So I've got my BP bot pawn right here. It's got a spring arm and a camera. And a mesh. That's all I need to do over there. And then I gotta start adding some controls to it. And I can do that. Okay, back to this goddamn tutorial. What time is it? Oh my god, it's almost 9 o'clock here.
There is a small detail. When
Oh, this is a 41-minute lesson. This is gonna take me. It's gonna take me 8 hours.
Are going straight forward, and that means that they're not exactly hitting what we're aiming at. If I'm shooting at this bot here, my projectiles are going under the bot, and that's not exactly what I want.
It's not what we want at all.
Is whenever I shoot, whatever my crosshairs are aiming at, I want my projectiles to hit that exact location. And to do that, we can make use of line traces. Now, we've used a line trace in the previous section when learning about collision. Line traces are a useful utility used very commonly in game development. Now, the way we can use a line trace is whenever we shoot a projectile, we can perform a line trace straight out into the world, from the center of the screen outward. If we perform this line trace straight out into the world, then that line trace is going to hit whatever we're aiming at, whatever's underneath the crosshairs, provided that those crosshairs are exactly in the center of the screen. If we do that, we can then get a hit result from that line trace. And the location of the hit is going to be something we can orient our projectiles toward so that they fly in that direction and hit exactly what we're shooting at. So let's do this line trace. We're going to do it from our bot pawn. And we can do it when we fire the rifle. So what we'll do is we'll go into our fire rifle function here. And the first thing we're going to do is perform a line trace. And we'll do this before everything else. That means before this branch as well. Now we can move that purple input node back and make room for the line trace nodes. But I really don't want this red wire going behind our nodes and crossing with things. So what I'm going to do is right click and use a get node for is left rifle, this input parameter here. As it's an input to the function, therefore we can use a get node for it. That way we don't have any wires crossing. Now that we've made some room, let's do a line trace by right clicking and searching for line trace. Now we have multiple line trace options here. The one I'm interested in is called line trace channel. This performs a line trace. And much like objects in the world have their own collision object types, which is a collision channel, a trace also has its own channel. Line traces can only use trace channels and not object channels. And in our project, we only have two collision trace channels, visibility and camera. By default, the trace channel is set to visibility, which means we're going to get a blocking hit on any component in the world that has collision data and is set to block the visibility channel. Now, we want to get a line trace hit on static objects such as the floor and walls and things like that in the world, but we also want to get a blocking hit on the bots
Kieran. What's going on? What are you doing? Hey? What's going on? What are you a little scared of? What's going on with her tail down there? Huh? You okay? Okay, go on, lie down, lie down. Turns rotation. I'm not enjoying this right now. I'm thinking I could figure this shit out on my own a little bit and get ahead of it. And honestly, I'm just feeling really stupid. Like, line trace by channel. I'm going to start it at my location. I want to end it with my forward vector plus 100. So why is my forward vector... Oh, it's because if I'm not moving, my vector is 0, 0, 0, 0, 0. No, it's still just always sends it to the middle. Do I take my active rotation and then times it by my forward vector? Okay, stop. Like, fuck, every time. No, I didn't change it. Alright, you know what? Let's just watch the fucking video.
Are BP drones. Now we can remind ourselves of the collision settings of the bot by going to BP bot, finding the bot mesh, and scrolling down to its collision presets. We see that we have enemy mesh here. And enemy mesh is by default set to ignore the visibility channel. So if we're going to use the visibility channel for our line trace, and we intend on hitting the mesh for BP bots, then we need to change one of two things. Either we need to trace against a different trace channel that the bot mesh blocks, which there are no trace channels that the bot mesh blocks, so we'd have to go and make a new channel. Or we trace against the visibility channel, and our BP bot's bot mesh blocks the visibility channel. Either one of those will work. And in serious games, usually a custom trace channel is created specifically for line traces associated with weapon attacks. So we could create a custom channel called weapon, for example, and trace against that, and our BP bots could block that. So there are different ways to go about this. To get things working though, we can simply make our BP bot block the visibility channel, and then we'll get trace hits if our line trace actually hits a BP bot's mesh. So to block the visibility channel, we need to change the collision preset enemy mesh. And we do that in project settings. So we can go to Edit, Project Settings, go to Engine, Collision, and under the preset dropdown, we can scroll down and find our custom enemy mesh. Now, I don't see it here, so I'm going to click on something else like Cinematic Camera and come back to Collision and scroll down, and there it is. It's a weird quirk with the editor. But I can find enemy mesh, I can select it, I can click on Edit, and I can choose to block the visibility channel for enemy mesh. As soon as I click Accept, I can come back to BP Bot, and I see that visibility has a block response. So now that we've taken care of that, we can go back to our BP Bot pawn and configure our line trace. Now, the trace start is going to be at the camera location. This will ensure that our trace begins at the middle of the screen, as the camera has a location at the center of the camera itself. So we can drag out and get our camera component, and we can use...
I guess that's the way to do it. The camera's still considered an act. No, okay.
Get world location. This is a function that belongs to the scene component class, and a camera inherits that function as the camera component is derived from a scene component. So it has that function, and that's going to be the starting point of our trace. But to visualize this, I'd like to draw a debug sphere so that we can kind of get an idea for this location in the world. So I'm also going to draw a debug sphere at the location of the camera. So we're going to hook that into the center. The radius for this sphere will be small, so 5. Line color can be a red, and duration can be 60 seconds. So we can go ahead and connect the wires to draw a debug sphere. And the camera world location is going to be the starting point for the trace. So I'm going to copy these nodes and paste them over here where we're doing the trace, and hook that location in to the line trace. We can also hook up these wires as well. So we're starting our line trace at the world location of the camera. The ending point for the line trace is going to be straight out in the forward direction of the camera. So let's make that trace end location. So we'll take the camera's world location, I'll copy those nodes, and we're going to add to this vector. And what we're going to add is the camera's forward vector. So we're going to get that camera's forward vector by using get forward vector. This is another scene component function.
I did this.
And
Why is mine not working?
are typically unit vectors. They have a length of 1. So we need to multiply this forward vector so that it's longer. So I'm going to multiply and
Okay,
convert.
hold on. So why do you have an addition there, which is confusing me, from the get world location. You've got to multiply down here. Oh, I just need to get forward vector. That's probably why. So can I not just do this? No.
Second pin to a float, and this will be the trace distance. This will be how far our trace will reach out into the world. Now this can be a variable, so I'm going to drag off and promote it to a variable, not a local variable, but a variable on the bot pawn itself, and this could be the trace distance. So I'm going to call this trace distance. It's going to be a float. And I'll go ahead and give it a category in the details panel. I'm going to make this category combat. And I can compile and give this trace distance a default value. Now this can be a large value, something like 5,000. So we have the forward vector scaled by 5,000, and if we add that to
right, it's because I have to take the world location and then add a forward vector to it. I can't just get a forward vector, right? Because that's its target. It's not its actual location. I need to remember this because this fucking throws me off all the time. I'm always thinking just get forward vector and my target is myself, but I don't actually have my location. And that's the thing. So I'm getting the location, call it 432, and then I am adding a forward vector to it, and that's my end. That's right. God damn, I gotta remember this. This shit hurts my brain. Oh. Just gotta remember that. All right. Get forward vector. I can't just get my forward vector and then add to it because I haven't defined. Get the world location. No wonder it's got issues every time I try this shit. That's where the line starts. Now I'm going to take my camera or location, get my forward vector, and then add a distance to it. Plug it in. Okay. I mean, once I start practicing this, it's just it'll be normal, you know. But really having to just remember this randomly. Compile. Thank you. Thing is, my line trace actually goes exactly where my crosshairs are pointing. So my crosshairs are lined up.
Location, then we get the end location of that vector. In other words, the location pushed out from the camera in the forward direction by 5,000 units. And we can visualize that by drawing a debug sphere at that location. Now I'm going to take this location and promote it to a variable, and this one will be a local variable, local within the scope of this function, because we only need to use it inside this function. And I'm going to call this trace end. So the trace end will be where we stop our line trace. Anything beyond that.
Oh, okay, so that's just right. All of this can be a variable. Good to know.
Point is out of reach of our line trace. So we'll go ahead and hook that up, and I'd also like to draw a debug sphere at this location as well. So I'm going to copy my draw debug sphere node and hook up the trace end as the center. Now this one can be a little larger because it's going to be farther out. I'll give it a radius of 20, and the line color can be a slightly more orange color. So we'll hook this up. And for our line trace by channel, we'll go ahead and use the trace end for the end location of the line trace. Now for the line trace, we're going to trace against the visibility channel. We don't want to trace complex. I want to trace against simple collision only. For draw debug type, we're going to draw a debug for the line trace so we can see a debug line and a point and see if we got a hit. So we're going to draw a debug for duration, and if I expand the dropdown, I can change the trace hit color or the trace color. I'm going to leave those as is. And for the draw time, I'm going to set it to 60 seconds so it lingers around. Now, if we want, we can input an array of actors to ignore for this trace. But there's also an ignore self boolean, a nice convenient setting that allows us to not have to worry about this particular actor being hit by the line trace. The bot pawn does not want to hit itself with the line trace, so we'll use ignore self to prevent that from happening. So right
So it's drawing it underneath.
Now all we're doing is a line trace and drawing debug spheres at the start and end locations for the trace, as well as a debug for the trace itself, which will consist of a line and a debug point. Let's go ahead and play test and see how this line trace behaves. I'm going to go ahead and press play, and all I need to do is fire the weapon a couple times. I'll just fire it once. And if we look behind us, we'll see the location of the camera. Remember, the camera is just behind our mesh and up a little bit. And our line trace goes straight into the world, and we got a hit on the floor. That's that little square there. That's a debug point. Now, we could go beneath our floor and see that our line trace extended out quite far. Remember, our trace distance is 5,000 units. And there's our second debug sphere, the larger one, with a radius of 20 at the trace end location. So we have a trace end, and we have a trace hit point. That's the point here where we actually got a hit by the line trace. Now let's trace against our BP bot actor and see if we get a hit when we're aiming at the bot. And sure enough, we did. We can see our line trace debug. We have a red line up to the hit, our debug point drawn at the impact point, and of course our line trace continues for 5,000 units, and the debug just shows it in green. Now these little small spheres are kind of getting a little distracting, aren't they? So I'd like to get rid of that actor, our sphere spawner, and we can also edit that sphere spawner so that that spawn time is not quite so short. I'm going to set it back to about 2 seconds. Compile.
Why don't you just delete it?
And I'm also done with the sphere spawner in this level, so I'm going to go ahead and delete it from the level so we can test a little better. Okay, so we know that our line trace is hitting what we're aiming at, exactly what we're aiming at. We can tell by taking a look at those debug points and seeing that they're appearing exactly at our crosshairs screen location. But we're getting a 3D space location, and that is something we can aim our projectiles at, so they always hit what we're aiming at, and we can stop missing like we're doing now with our blaster beams. So the next piece of this puzzle is to orient our blaster beams. So let's go back to our bot pawn and decide how we're going to use the information from our line trace. Now here's the thing, our line trace may or may not get a hit.
How did my dude end up so fucking weird out here? Oh. Let's do 100 on the Y. Get a hit if our line trace doesn't hit anything. If I aim up at the sky, for instance. Well, there's our line trace, and as we can see, we never actually got a hit. So the hit result produced by our line trace will not contain any valid data in this case because we never hit anything. So in that case, we need to orient our projectiles at the end point here, where we have our larger orange sphere. But if we did get a hit, we want to orient our projectiles at that hit result location of the trace. So we can check in BotPawn to see if we got a hit. It's something we can aim our projectiles at so they always hit what we're aiming at, and we can stop missing like we're doing now with our blaster beams. So the next piece of this puzzle is to orient our blaster beam aiming at the about this particular actor being hit by the line trace. The BotPawn does not want to hit itself with the line trace, so we'll use ignore self to prevent that from happening. So right now, all we're doing is a line trace and drawing debug spheres at the start and end locations for the trace, as well as a debug for the trace itself, which will consist of a line and a debug point. Let's go ahead and play test and see how this line trace behaves. I'm going to go ahead and press play, and all I need to do is fire the weapon a couple times. I'll just fire it once. And if we look behind us, we'll see the location of the camera. Remember, the camera is just behind our mesh and up a little bit. And our line trace goes straight into the world, and we got a hit on the floor. That's that little square there. That's a debug point. Now, we could go beneath our floor and see that our line trace extended out quite far. Remember, our trace distance is 5,000 units. And there's our second debug sphere, the larger one, with a radius of 20 at the trace end location. So we have a trace end, and we have a trace hit point. That's the point here where we actually got a hit by the line trace. Now let's trace against our BP bot actor and see if we get a hit when we're aiming at the bot. And sure enough, we did. We can see our line trace debug. We have a red line up to the hit, our debug point drawn at the impact point, and of course our line trace continues for 5,000 units, and the debug just shows it in green. Now, these little small spheres are kind of getting a little distracting, aren't they? So I'd like to get rid of that actor, our sphere spawner, and
We can also edit that sphere spawner so that that spawn time is not quite so short. I'm going to set it back to about 2 seconds, compile, save that, and close it. And I'm also done with the sphere spawner in this level, so I'm going to go ahead and delete it from the level so we can test a little better. Okay, so we know that our line trace is hitting what we're aiming at, exactly what we're aiming at. We can tell by taking a look at those debug points and seeing that they're appearing exactly at our crosshairs screen location. But we're getting a 3D space location, and that is something we can aim our projectiles at, so they always hit what we're aiming at, and we can stop missing like we're doing now with our blaster beams. So the next piece of this puzzle is to orient our blaster beams. So let's go back to our bot pawn and decide how we're going to use the information from our line trace. Now here's the thing, our line trace may or may not get a hit. We won't get a hit if our line trace doesn't hit anything. If I aim up at the sky, for instance, well, there's our line trace, and as we can see, we never actually got a hit. So the hit result produced by our line trace will not contain any valid data in this case because we never hit anything. So in that case, we need to orient our projectiles at the end point here, where we have our larger orange sphere. But if we did get a hit, we want to orient our projectiles at that hit result location of the trace. So we can check in bot pawn to see if we got a hit. Our return value for line trace by channel, this boolean, will be true if we got a hit and false if we did not. And also our hit result itself, out hit, once we take that out hit, drag it out and break the hit result, it also has a boolean called blocking hit, which will be true if we got a hit and false if we did not. This is useful information because if we did not get a blocking hit, then we can't go into our hit result and expect our impact point or any other information here to be valid, because it's only valid if we got a hit. So what we want is to use the impact point from our hit result if we got a hit. But if we did not get a hit, we want to use our trace end. So to be efficient, what I'm going to do is check that blocking hit boolean, and if it's true, then I'm going to overwrite that trace end with the impact point. But if it it's false, I'm just going to leave trace end set to what it was before. In other words, we can do something like the following. We can have a branch, and for the branch condition, we can check blocking hit. And if blocking hit is true, then we can take our trace end and we can set it with a set node equal to impact point like this. And if it's false, well, we can just leave trace end alone. The equivalent of setting trace end like this equal to itself, which would be just not changing it at all. Now, using a branch like this involves a lot of crossing wires, and that's one way to do it, but there's another handy node we can use to achieve the same result, and that is the select vector node. This is a math utility. If we get this node, well, check it out. Select vector returns a vector value, and that vector value will be the value of A, which can be either hard-coded with zeros, as we see here, or it can have a value passed in, or the return value will be B, and which one, A or B, well, that depends on the Boolean passed in, which is called pick A. If pick A is true, then the return value of select vector will be A. If pick A is false, the return value will be B. So we can set the value of trace.
Interesting though, how... Oh, right. So it does go through it in an order. I thought it didn't for some reason. I thought everything that was there lined up. Just... Huh. Okay. Oh, this is working. But again, this laser is coming out from me. It's coming from the camera. It's not coming from my bot.
Trace end to whatever this select vector returns. And our condition for pick A can be this blocking hit from the trace result. So if blocking hit is true, then trace end will be set to the value of A. And if it's true, if we got a blocking hit, then our impact point is valid. So we're going to take our impact point and hook it into A. Now I'm going to go ahead and collapse this node so it's nice and compact. But what if blocking hit is false? Well, that means that our hit result does not have valid data, and trace end just needs to be set to itself. We don't want to change it, so we're going to get trace end and hook it into B. So now we have a nice compact way to set trace end equal to itself if we don't have a blocking hit, and the impact point if we do have a blocking hit. So I'm going to go ahead and hook this set node up, and now we know that set is going to be set to one of two locations. If we didn't hit anything, as in the case where we shoot up into the air and we never hit an object with our line trace, well then now trace end will be set to that trace end, what it was before essentially. But if we did hit something, like the floor, then instead of trace end being way out there, it's now going to be set to the point here, the point of our hit. And now that we have a trace end point, we can use this point when we spawn our projectile. What we want is to orient our projectile so that it's facing that trace end location. So when we're spawning the actor, we can set its transform such that its rotation is oriented correctly. So here's what we're going to do. We're going to take our get socket transform. We're going to hold Alt and break that node. We're going to right click on its to itself if we don't have a blocking hit, and the impact point if we do have it. And now that we have but if we did hit something like the floor, then instead of trace end being way out there, it's now going to be set to the point here, the point of our hit. And now that we have a trace end point, we can use this point when we spawn our projectile. What we want is to orient our projectile so that it's facing that trace end location. So when we're spawning the actor, we can set its transform such that its rotation is oriented correctly. So here's what we're going to do. We're going to take our get socket transform. We're going to hold Alt and break that node. We're going to right click on its return value pin and split struct pin. We're going to split the struct pin for the spawn transform input for spawn actor. We'll go ahead and split that. And for the location of the spawn actor node, we want that to be the same thing, the socket location. That's where our blaster beam will spawn into the world. But now we want its rotation to be different. We want it to be oriented at our trace end, where we got our line trace hit. So how do we get the rotation that corresponds to that direction? Well, there's a handy node that we've used before called find look at rotation. Find look at rotation takes a starting point and a target and returns a rotation corresponding to that. We have a start location, that's the socket location where we're spawning in our blaster beam. And we have a target location, that's the trace end. We're going to stick that into find look at rotation, and this result will be the rotation we give our blaster beam when we spawn it into the world. And now our blaster beams will be oriented correctly. They'll always fly towards that trace end location. Let's test that out.
Just gonna head towards where the impact is. Now, if he's moved, obviously he's not gonna impact. Okay, so it's essentially going from my character, from my camera. It's spawning there, but it's heading towards wherever my camera impacts. I get it. Now, does that mean if he's super close to me, that potentially I could miss him if my camera's massively offset? I think it does. No, because it's still coming out of my guy. It's just heading in that location. Even though my trace didn't hit him, it's just getting an end mark. Yeah, okay. I mean, that makes sense. That's where it's aiming to. It's still going to collect collision along the path. Okay, I get it. It makes sense. Okay, that's cool.
Shooting in our world. So pay close attention to the crosshairs on the screen, and as we fire, look at that. Our projectiles, our blaster beams, are impacting exactly where we're aiming. So if we aim at the bot, for instance, we should hit it. Boom. And there we go. Now, if we don't hit anything, then we're just aiming at that end location. So our projectiles will for sure go through that end location here. So we know that we'll always hit at least that trace end location. But if we hit something before that trace end, like the floor or a bot or really anything, we're always going to hit that point that we aimed at. This is a common technique used in shooter games, and because we're shooting a rifle, this is a shooter game. So now we have these line traces guiding our projectiles at the correct location. The only thing left after developing this is to remove those debug lines, points, and spheres, and that's easy. We just go back into BotPod, into Fire Rifle, we go and find our line trace by channel node. And for draw debug type, we set that to none. And now we'll no longer see those lines and the debug points. What we will see are those debug spheres. So we can get rid of those as well by going back to BotPawn and getting rid of the draw debug sphere nodes. We don't need those anymore, so we can go ahead and remove them.
So just looking over this again, okay. We're going to get a world location of the camera right here. Draw the debug sphere on us. We don't really need that anymore. So we fire the rifle. We're going to get a world location. Then we're going to get a forward vector. We're going to times that by a distance. We're going to add a world location. Get world location. Get world vector. To set an end mark. To set as trace end. No. Line trace there. Hit result. If we hit something, then we are going to set our new trace end to be there. If we don't, then we don't worry about it. Then over here, yeah, set the name. Because we're flip-flopping and changing the rifle name outside. We're going to spawn the actor class. It's got a projectile on it. We're going to get the socket location. There's the botnest. There's the socket name, which is going to swap in between due to the flip-flop. And then we are going to spawn the blaster right there from the socket. Its rotation and then we're going to find the look at. So it's starting from there and its target is there, and that's its new rotation. Right, yeah, right there. Spread these out a little more. That's better. What's going on over here? Okay. There's this. We're going to spawn it there. Our rotation is going to be the look at rotation. We know where we're spawning it from. Look at rotation is starting from the socket location, and then we're sending it towards the trace, and that is its new spawn. Shit. Okay. Feels good.
And now all that's left.
I think my biggest thing is, like, how the fuck am I going to remember all this? Even just, like, going in now and, like, adding a fucking box into the world and adding a world offset to it and then rotating it. It's like, I literally have to go through this entire fucking tutorial again just to remember how to add controls. I think that's the part that makes me sad. But again, like, there's another game coming up, and I'm going to probably hopefully add controls from the ground up on that one. And doing that again will definitely help. But I might just fuck around with my other little level I got there. Just add a box, add a player controller, and then add world offset to the box, and add rotation. And then maybe line trace off a gun from the top. I'm gonna try and see if I can do that. Once I'm done this lesson, that's what I'm gonna do.
Left is setting the trace end. We don't want to remove that. That's a good one. And the line trace itself, we don't want to remove that either. So now we have the same functionality, but no debug. All we have is a perfectly working aiming system that will allow us to shoot and hit what we're aiming at, which is always nice when it comes to shooter games. All right. Great job in this one. And perhaps the last thing we could do is a little bit of cleanup here. We can refactor some of these nodes into functions. For instance, this one here is calculating the trace end for our line trace. We can collapse this to a pure function. Can't we? So let's right click on it. We can collapse to function and we can call this get trace end. We can convert it to a pure function, and now we have a nice compact way to get our trace end. Now, we don't want to call get trace end everywhere we're using it. It's more performant to cache it off like we're doing here and just use the value of the variable that we've stored. Otherwise, if we had a get trace end here plugged into the line trace, well, then we'd be calculating it once and then calculating it again, and we don't want to calculate it twice when once will do. So we'll just use the trace end local variable where we stored the value rather than calling that blueprint pure function again, which would result in another calculation. Same goes for all blueprint pure functions, really. So we are calling get world location again here when we're already calling it in get trace end. So if you wanted an even more optimized solution, you could cache off the camera's world location first, but get world location is a relatively cheap operation, so we're fine there. And the last thing we could do if we wanted to is collapse these nodes to a handy little function for performing our line trace. So if we wanted, we could right click, we could collapse to function and call this rifle trace solution. You could cache off the camera's world location first, but get world location is a relatively cheap operation, so we're fine there. And the last thing we could do if we wanted to is collapse these nodes to a handy little function for performing our line trace. So if we wanted, we could right click, we could collapse to function and call this rifle trace. And now we have a nice, neat little set of nodes, and our function is a little bit more manageable. And in a serious project, I would probably refactor this function just a little bit more by taking the sound and visual effects and collapsing those to a function. I can right click here, collapse to function, and call this spawn fire effects. And that way we know that this is all the visual stuff involved in firing a rifle. We simply spawn the system at the hit location of the socket and play a sound at the location. We can get that all taken care of in that little function. So now fire rifle is looking even more manageable. And we could even package up these nodes into a function to get that spawn transform. Here's what that would look like if we wanted to create a blueprint pure function to calculate the spawn transform. We could take any one of these values, such as the location. We can use make transform to get a make transform node. We can hook in that rotation to make transform. We can hard code a value of 111 for the scale. And then we can take this return value and hook that in to spawn actor. We can recombine the struct pin and hook in that spawn transform. We could take in of the socket and play a sound at the location. We can get that all taken care of in that little function. So now fire rifle is looking even more manageable. And we could even package up these nodes into a function to get that spawn transform. Here's what that would look like if we wanted to create a Blueprint Pure function to calculate the spawn transform, we could take any one of these values, such as the location. We can use make transform to get a make transform node. We can hook in that rotation to make transform. We can hard code a value of 111 for the scale. And then we can take this return value and hook that in to spawn actor. We can recombine the struct pin and hook in that spawn transform. And now we have some nodes we can collapse to a pure function here. Make transform to get a make transform node. We can hook in that rotation to make transform. We can hard code a value of 111 for the scale. And then we can take this return value and hook that in to spawn actor. We can recombine the struct pin and hook in that spawn transform. And now we have some nodes we can collapse to a pure function here for the spawn transform. So we can right click, collapse to function, and call this get spawn transform and make this pure. And now get spawn transform is refactored into its own little function where we're doing the same thing that we did before, only our trace end here. This is now a local variable, and that's not what we want exactly. And we can tell because it's a little bit grayed out. Notice that it looks a little bit gray, and that's because it doesn't exist in this function. If I compile, we'll see there's an error. So what we need to do is we need to pass trace end into our function as an input parameter. We can do that by selecting the node and adding an input of type vector here, or a shortcut is to take this target and just drag it onto the input node, and then we have an input. We can call this trace end. And now we need to pass in a value to this function. The reason we couldn't just use the trace end is because that trace end is not a member variable on this class. It's local to the fire rifle function. Remember, this is a local variable here in fire rifle, so another function isn't going to know the value of trace end. We have to pass it into our Blueprint Pure function, so we can get a trace end and hook that in here. So what we say is that trace end is in scope here in fire rifle. It exists here. It's only in scope here in fire. rifle. It doesn't exist outside the function. That's why get spawn transform didn't know about it. But we can pass it into get spawn transform using that trace end. And now our fire rifle function is looking quite good. If we wanted one last refactor, we could take care of this business here by getting the socket name based on whether or not it's a left or right rifle. Now, is left rifle is an input parameter to this function. Again, it doesn't exist outside the function, so we could make a function that takes in a Boolean and perhaps returns a socket name, rifle L or rifle R, depending on that Boolean. Here's how we could really quickly do that. We can add a new function. We can call this get. See, that is a little neater, like that trace end passed in. And in fact, rifle trace, and then we don't need to use that member variable there. And in fact, our blueprint pure function, it doesn't exist in this function. If I compile, we'll see there's an error. So what we need to do is we need to pass trace end into our function as an input parameter. We can do that by selecting the node and adding an input of type vector here, or a shortcut is to take this target and just drag it onto the input node, and then we have an input. We can call this trace end, and now we need to pass in a value to this function. The reason we couldn't just use the trace end is because that trace end is not a member variable on this class. It's local to the fire rifle function. Remember, this is a local variable here in fire rifle, so another function isn't going to know the value of trace end. We have to pass it into our blueprint pure function, so we can get a trace end and hook that in here. So what we say is that trace end is in scope here in fire rifle. It exists here. It's only in scope here in fire rifle. It doesn't exist outside the function. That's why get spawn transform didn't know about it, but we can pass it into get spawn transform using that trace end. And now our fire rifle function is looking quite good. If we wanted one last refactor, we could take care of this business here by getting the socket name based on whether or not it's a left or right rifle. Now, is left rifle is an input parameter to this function. Again, it doesn't exist outside the function, so we could make a function that takes in a Boolean and perhaps returns a socket name, rifle L or rifle R, depending on that Boolean. Here's how we could really quickly do that. We can add a new function. We can call this get socket name. Get socket name can take in a Boolean. Called is left or is left rifle. We can check with a branch is left rifle, and we can output a name by clicking get socket name and clicking on plus for an output, and we can call this socket name. Or if we want to be more specific, we can call this rifle socket name, but we're just going to call it socket name. It's going to be a name. And if is left rifle is true, we can return rifle underscore L, and we can have another return node. If is left rifle is false, in that case we'll return rifle R. Pretty simple function. Returns one value or another. Based on the Boolean. So we have this function now. We can go back to fire rifle and call it getSocketName, and we can set this socket name variable to the result of it. Passing in is left rifle for that Boolean. And then we don't need this branch here. All we need to do is call that function and set our socket name here. And get spawn transform rifle and call it getSocketName, and we can set this socket name variable to the result of it. Passing in is left rifle for that Boolean. And then we don't need this branch here. All we need to do is call that function and set our socket name here. And get spawn transform uses the socket name. This is a member variable on the function. That's why we can use it in here. But if we didn't want that to be the case, we could just pass it into get spawn transform as an input by dragging that socket name in. By default, it's called in socket name. We could even leave that and delete the socket name there. Now it's clear that get spawn transform needs that socket name. And if we go back to fire rifle, we can see that right here, get spawn transform needs that socket name, and then we can just pass it straight in from get socket name there, like so, and then we don't need to use that member variable there. And in fact, get spawn transform can simply use get socket name. We could combine these into one node, get spawn. And get spawn transform uses the socket name. This is a member variable on the function. That's why we can use it in here. But if we didn't want that to be the case, we could just pass it into get spawn transform as an input by dragging that socket name in. By default, it's called in socket name. We could even leave that and delete the socket name there. Now it's clear that get spawn transform needs that socket name. And if we go back to Fire Rifle, we can see that right here, get spawn transform needs that socket name, and then we can just pass it straight in from get socket name there, like so. And then we don't need to use that member variable there. And in fact, get spawn transform can simply use get socket name. We could combine these into one node. Get spawn transform could perform that Boolean check, get socket name here. We can come in here and call get socket name. And then we don't need a socket name passed in to get spawn transform. We can take that input and remove it. And here we call get socket name first, and then pass the socket name into get socket transform next. And now our get spawn transform just needs a Boolean. We can hook that in to get spawn transform there, and make sure to hook up our, and in fact, get spawn transform can simply use get socket name. We could combine these into one node. Get spawn transform could perform that Boolean check, get socket name here. We can come in here and call get socket name. And then we don't need a socket name passed in to get spawn transform. We can take that input and remove it. And here we call get socket name first, and Then pass the socket name into getSocketTransform next. And now our getSpawnTransform just needs a Boolean. We can hook that in to getSpawnTransform there. And make sure to hook up our nodes, like so. And now getSpawnTransform calls getSocketName first. And now we don't have to worry about making sure that that socket name is formed there. And make sure to hook up our nodes, like so. And now getSpawnTransform calls getSocketName first. And now we don't have to worry about making sure that that socket name is determined before we go and use it in getSocketTransform. And just to clean this up just a bit, I'm going to take that trace end wire and just use trace end using a get node there so we don't have too many wires going across. And now this function is a little neater, like so. So getSpawnTransform now just takes a Boolean so back to Fire Rifle, we don't need to call getSocketName anymore. We can pass isLeftRifle in to getSpawnTransform. So we can no longer call getSocketName. All we need is getSpawnTransform. we don't need to call get socket name anymore. We can pass is left rifle into get spawn transform. So we can no longer call get socket name. All we need is get spawn transform. Takes in a trace end and a Boolean, and that's it. So now fire rifle is much more simple. It simply gets the trace end, fires the rifle trace, gets the spawn transform, spawns the actor, and spawns the effects. Now, just like we did with get spawn transform, we could combine these nodes, and it's usually a good idea if this rifle trace depends on getting this trace end first. We can make sure the rifle trace gets that trace end passed in. And in fact, rifle trace can't use trace end unless we pass it in, right? Because this doesn't exist in this function. That's why it's grayed out again, and we get the error there. So what we can do is make trace end a input to rifle trace. We can call it trace end, like so. And now if we compile, we'll see that trace end actually exists here. And we can't just set trace end, the local variable. We have to output it from rifle trace. So we could take rifle trace, we can click plus to give it an output. We can make it a vector, and we'll call this trace end. We'll call it trace end location, so it has a different name. And at the very, very end here, we're going to return the value of trace end, which is calculated by our select node here. So now we have our trace end location. And I'll just reroute the nodes here. So rifle trace takes in a trace end, but then outputs the trace end as well. So back in fire rifle, we can calculate trace end first and hook it into fire rifle. And then the trace end location is output, and we can pass that into get spawn transform. There we go. And now we're not using the trace end local variable here. We can simply bypass that set node altogether and pass get trace end right in to rifle trace, like so. And in fact, we can just call getTraceEnd inside of rifleTrace right here and not even need to pass it in. We can simply remove the TraceEnd input parameter altogether and call getTraceEnd here. And we can pass it into the line trace, or since we're using it twice, we can have a local variable TraceEnd here. Promote to local variable, call it TraceEnd, and now we're calculating it just once and inside of rifleTrace right here and not even need to pass it in. We can simply remove the TraceEnd input parameter altogether and call getTraceEnd here. And we can pass it into the line trace, or since we're using it twice, we can have a local variable TraceEnd here. Promote to local variable, call it TraceEnd, and now we're calculating it. Just once and passing in TraceEnd where we need it. So we'll have it here. And we're using it here as well. And now there's less chance to mess things up because we're only calling get trace end where we need it in the rifle trace function here. And if we go back to fire rifle, now we don't have to call it outside the function. We're just calling it here. We have one rifle trace function, which we can use to get the spawn transform for the actor we're spawning. So as you can see, refactoring our code is an iterative process. When you have have one function that has to be called before another function, it's a good idea to keep those right next to each other so it's clear. We need the trace end first before we use it for our line trace, and then once our line trace is done, we take that result and produce it from this function, which we can then use to get the spawn transform and pass that in to spawn actor. And if you wanted to, you could combine these two nodes into a function for getting the spawn transform as well. And as we've done this process several times already in this video, this is going to be a challenge for you. Next to each other so it's clear. We need the trace end first before we use it for our line trace, and then once our line trace is done, we take that result and produce it from this function, which we can then use to get the spawn transform and pass that in to spawn actor. And if you wanted to, you could combine these two nodes into a function for getting the spawn transform as well. And as we've done this process several times already in this video, this is going to be a challenge for you. I'd like you to refactor the two nodes rifle trace and get spawn transform into one handy function that can take in a boolean for is left rifle and out input a transform. So all we really need to do is collapse these first before we get the spawn transform. So pause the video and give this a try. Okay, so all we really need to do is collapse these nodes to a function. I can make sure that that red line is outside of my selection first before selecting these two nodes, collapsing to a function. And this can be called, I'm going to call it trace for spawn transform. That way we know that it's doing both a line trace and calculating the spawn transform. So now we have one function, and inside of it, we're performing the rifle trace and getting the spawn transform and returning that transform. And as is always a good idea, we can play test to make sure that this is working by going back and shooting a couple of blaster beams. And as we can see, our beams are hitting exactly what we're aiming at. Which is perfect. Excellent. So we've gotten a lot of practice refactoring our code, and the end result is that we have a nice, neat event graph. It looks a lot better. All the way out to our main event graph, we can look at our IA fire. We can see that we have fire rifle, takes in a Boolean for left or right. And then if we look in that, we can see, oh yeah, this makes a lot of sense. It's easy to look at. All we know is this function just requires a Boolean. It's a black box. We don't have to know how it works. And it returns the spawn transform for the actor. And then we can treat our spawn fire effects as another black box we don't have to worry about. And then if we do need to worry about it, we can double click to go in and see what these functions are doing. And again, it's simple. It's easy to see. All this function does is performs a trace, calculates a spawn transform, and returns a transform. And we can always dig one level deeper at a time and see the implementation details of each individual step. And this is, in general, a good way to structure our code. And you'll notice as you go that certain things might be not so necessary, such as this is left rifle. This is just an input parameter to the function. It was initially being used to prevent crossing wires, but because this is so close to the function input itself, we could just drag that wire across and get rid of that node. And now it's a little bit better, a little bit neater. So you'll find ways to make your blueprints a lot neater as you go. So now now that we have our rifles firing how we want and our code is structured well and it's nice and neat, we can move on. Excellent job, and I'll see you in the next video. Welcome back. in our pawn. Our mesh, we're going to add because I dragged one in. View is changed. It's now here, but it's at the root. In fact, if at low panel, arm pawn with a given player index input system. Enhance and right click, choose new folder, and call this folder input. We'll go into input and we'll make a new type of asset here related to input. Let's right click and find the input category. And here in input, we're going to choose input action. Now, before I click on it, take a look at the pop-up and read it. The first line says, an input action is a logical representation of something the user can do, such as jump or crouch. These are what your gameplay code binds to in order to listen for input state changes. We're going to see what that means very soon. Let's go ahead and click on input action. And we prefix our input actions typically with IA, which stands for input action. Now I'm going to call this IA fire, as in firing a weapon. This is going to be a very simple type of input action. I'd like this to represent the action of firing a rifle. I'm going to double click on it and open up the input action asset. Here's what it looks like. It's quite simple. And really the most important thing to look at here is the value type, which has a dropdown. It says digital bool, and we know that bool or Boolean data types have only two possible states, true or false. An input action that has a value type digital bool is the most basic type of input action. It's usually for a single button press. The input action contains the information vector2 with some kind of input. Let's choose that. The mapping context is what we use to link an input action to a given type of input, a certain button or key, etc. Let's open that IMC bot, which again, just like input actions, it's kind of basic, but we need to take a look at mappings. Mappings here is an array. We can add elements to it with the plus icon. And as soon as we do that, we have a dropdown we can expand. And we have a single mapping here, which has its own triangle we can expand, and its own dropdown where we can select an input action. Now, there only exists one input action in our entire project. That's IA fire. That's the only choice we have. So we can select that, and our dropdown now says IA fire. And if we expand its triangle, here is where we can choose which key is going to be associated with this input action. Which key do we want to press to fire our weapons, right? Now, we can choose the key or button or any other type of input from the dropdown. If we expand it, we see lots of different categories. If I want the left mouse button, I can find mouse, expand it, and there are different types of mouse input. Most notably is the left mouse button. We can choose that there. And now IA fire has the left mouse button associated with it. Now we can remove that association by clicking the trash can, which says remove mapping. That's going to remove the entire mapping. So if you did that, go ahead and click plus to add that IA fire back. Now, rather than going and searching for the key or the mouse button, there's a shortcut. We can click on this icon here, select the key value. If we click on it once, it becomes yellow, and we can then press any key on the keyboard, such as the F key, and now F is associated with IA fire. And we can do the same thing for mouse buttons. I can click on it and click the left mouse button to associate the left mouse button to IA fire. Now, the cool thing about input mapping contexts is we can associate more than one button to a single input action. We do that by pressing the plus icon next to that mapping. Not the plus icon next to mappings, but the plus icon next to the individual mapping associated with this input action. action. If I click on plus, I now have an additional input associated with IA Fire, and I can choose what that key can be. I can click on the keyboard and press F, which is a shorthand for finding the F key under keyboard here and searching for it and selecting it. So now left mouse button and the F key are both associated with IA Fire. All right. So the input mapping context is where we tie inputs to the input action. And the way to do it is as follows. And don't worry if you don't commit this to rote memory, because you can always come back to this video and remind yourself how it's done. But the way to do it is as follows. First, we need to access our controller. You see, when we possess a pawn, we do so through a controller. Others don't have it because they don't access the controller. We right-click and search for Get Controller. And we choose Get Controller. This is a function on the pawn class. Actors don't have it because they don't get possessed by controllers. Pawns do. And if we hover over the return type, its type is controller object reference. Now, controller is a base class. It's a parent class, which is very basic. But our pawn has a more specialized child class of controller called player controller. And we need the player controller. We need our controller in the form of the player controller data type. And remember, this is what casting is for. So we can drag off of that controller data type and search for cast to player controller and choose that. And the return type here says player controller object reference. This is a child class of the controller. A player controller is a controller, right? We have that is a relationship going on. So in begin play, we're going to access the controller that's possessing this particular pawn, cast it to player controller. And why did we need it in the form of a player controller? Well, that's because we need to access something called the Enhanced Input Local Player Subsystem. Notice under player controller, under local player subsystems, we have this function to get enhanced input local player subsystem. Now, a subsystem is an object that exists in our game. There's only one of them, and we can access it through this get function that belongs to the player controller. If we click on this get enhanced input local player subsystem, we have this one big fat node that returns an enhanced input local player subsystem object reference. And this is how we associate input mapping contexts. We drag off of it and we search for add mapping context. If we select it, we now have a new function call to add mapping context. This is where we can choose the mapping context we want to add. We have to connect this to our cast node. Make sure you don't use cast failed. We need the top execution pin. And we can choose the mapping context from the dropdown. Our project only has IMC bot, so I'm going to choose that. Now there's a priority because we can add multiple mapping contexts at varying priorities, and the mapping context with the highest priority takes precedence. Let's say I had two of these with different input actions associated with the left mouse button. If we had both mapping contexts added at the same time, the one with the highest priority is the one that's going to trigger that left mouse button input action. But anyway, now we've added our input mapping context here and associated it with this given controller, and this opens some interesting doors for us. We now have the ability to make use of our IA Fire input action, which exists in IMC bot, our input mapping context, which we've used to associate the left mouse button and the F key with it. So I'm going to go ahead and remove these two nodes, tick and active begin overlap. We don't need those. And this set of nodes here, where we're adding the input mapping context, this can get its own comment. You could even collapse it into a function if you'd like to do that. But I'm just going to press C to give it a comment and say add bot input mapping context. And I'll go ahead and give it its own color. We'll give it red. Something I like to do is double click the wire here to give it a reroute node. That way, if I need to move the comment around, it's going to anchor to that little reroute node there. So now that we've added the input mapping context, we can choose what happens whenever we trigger the IA Fire input action. In other words, the keys and buttons we've associated with IA Fire in the IMC bot input mapping context are going to trigger some kind of functionality. We can determine what that is by going to our bot pawn here, right-clicking in the event graph and searching for IA Fire. Now we have two options here. Something that has a little arrow indicating that it's an event. If we click on that, we have this event we can implement, and we can expand its dropdown, and we see that it has a number of execution pins and data values that it provides. So we can choose what happens in response to under enhanced action values. This looks like a blueprint pure function, right? And that's what it is. Because our IA Fire has its value type set to digital bool, there's a blueprint pure function that returns the Boolean value that'll be true if those inputs are being pressed currently. If they're not being pressed, the value will be false. So that's a convenient way to check to see if the F key or the left mouse button are currently being held down. But this IA Fire event, we can say triggered. You see, we have a number of things that will trigger based on the status of that input. The first one, triggered, will be executed every frame as long as the input is held down. We can prove that with a print string node. We can say triggered. We also have started, which is only executed once when that input is pressed. We can add a print string node for that one, and we can say started, and I'm going to change its color to a more reddish color here. Now, ongoing and canceled have
The fastest and easiest way to make moving and rotating. Hello and welcome to another Unreal Engine tutorial. Right click and change the behavior type to ping pong. The quickest way to add particles
I got this, buddy.
It's my treat.
The new $6 Buddy Bundle.
Hello. I wanted to make a little video about world position offset after I figured out some stuff today.
Bum 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 bum.
Hello, actor. Add 100 to my and it's going to go up again. So here's our add actor world offset node. Let's go ahead and add actor world. We're not going to find it. Uncheck context sensitivity. And we can find add actor world offset under utilities transformation. And this is how it's going to come in by default. It's going to take in an actor. That's why we couldn't find it earlier. It's going to take in a location. This is basically our new X, Y, and Z that we're adding to our actor. And then you can choose to sweep or teleport for the booleans. And if we sweep, we have a hit result. Now, you could split our location, because it is a struct, into our X, Y, and Z floats. And I actually have the world and the local versions here, just to show you comparison-wise. And if you look at them, they're going to be the same. The difference is the world offset node applies it based in world coordinate space, whereas the local applies it to the local. What do I mean by that? Well, it's pretty simple. We'll go ahead and hit play. We are going to eject and choose our cube here. And we're going to go ahead and toggle between world and local, which is our little node here. And you should see no difference. Well, we have no difference, that's why. I'm going to change my rotation of this item on the Y to 45. Now you'll notice when I toggle my coordinate system, we have a difference. The world coordinate system is Z up, X in this direction, and Y in that direction. The local coordinate system of this cube, however, is different because I've modified it by 45 degrees. So you'll see how our X now goes that way. Our Y technically will go in the same direction, but our X and our Z are different. Now using the local offset version, we're going to offset it based on this coordinate system. Using the world offset version, we're going to offset in the world. So if I did Z100, even though I have rotated this cube, I'm moving it up no matter what. So basically, even if the rotation has been changed on this actor, the world coordinate system will remain the same, and it will adjust it as needed.
how do I move? And here we go. I already created. Let's start with this. And I'd like to start adding like a simple cube, okay? Set the spring arm as a... So a game which is running at 60 FPS will have this element fired 60 times per second and all the relative functions which are connected to it. Where a game which is running at 30 FPS will have this element just called 30 times per second. And this is leading us to another problem, which is the frame dependency. Because if we are applying an offset like 3, let's say, and we are doing it on a game which is running at 60 FPS, it means that this object at every frame is getting moved of 3 units. So a game which is running a higher FPS will result into having this actor moving way faster. And this is something we absolutely do not want, because we'll make stuff running different from PC to PC, okay? So what we want to do in these cases is taking always into account and into calculations the delta seconds, which is the difference of time between the last 2 frames, okay? And we can also use world delta second, which is the same value, but is taking into account also the time dilation, so the slow motions or fast forwardings and this kind of stuff. We will speak about the frame dependency into another tutorial. This topic deserves a whole video on its own. So let's get back on our movement. We set 3 as a value. So if we go now into our actor here, into our pawn, he will move, pressing play, of 3 units over the x-axis per frame. And let's see. And he's moving fine. So why we are not using this camera? Because we didn't set the auto possess player here, and we can just set it to player 0. This way, we will just possess the pawn, and as a consequence, having this camera as active one. So, okay, we want to be able to control the movement of our actor, okay, since we also just created the inputs into our project settings. So, let's write front movement and side movement. So those are our inputs values, okay? We can drop from here and say make vector. So this way we're going to create a vector with the value of x, which will be the movement front, and the y over the side movement. We can leave the z blank because we'll need to fly, so we can leave it like this. What we want to do now is absolutely to normalize this vector to get like a directional vector. So normalize, and this way we're gonna just get a simple direction, okay? Then we multiply it for a value which will be the amount of offset we want to apply at every tick, okay? So this value will be example 3.
for a couple of seconds to, let's say, 2 seconds. Going to, well, there's a couple ways. First, we can check to see if target pawn has a valid value first before we try to use it. There's a couple ways to do that. The first is to get our target pawn, drag off of it, and type is valid. Now there's and we have outputs. It actually did. And if not, question mark, we have some. And we have this other type of node with a question mark. Now, if we choose the one with the question mark, we have something that kind of looks like a brand is not. Another way executes the is valid execution. And if not, executes the is not valid execution, which we could put some kind of a print string there if we wanted to, based on the status of that input. The first one, triggered, will be executed every frame as long as the input is held down. We can prove that with a print string layer control. We right-click and search for get controller. And we choose get controller. This is a function controller object called to cast it to play. We have IMC here. If we click a blueprint,
Are we going to hit? Now I actually want the wall to stop. Overlap, times, hits, everything in your normal hit result, which you can check out the video for on that one. And to show you that it works, let's move this 500. Look in the top left, and you'll see true. We were actually blocked from moving 500 units completely.
like textures that you imported, right? Like you go and import like 10 of them. It's like, oh, which one did I edit? Which one did I not?
Yeah.
And then it becomes so tedious and monotonous that it's like you almost like kind of zone out.
Yeah.
It definitely slows you down just because of how boring it is. Welcome, Pretty Bad Games. Or
Sorry, apparently my mic was muted.
or do you prefer Matthew Sucks?
Oh man, I'll take any of it. I'm pretty new to Unreal.
Turn back
Hey,
while you
welcome.
still can.
I'm so frustrated right now, to be honest. I've been going through the tutorials on Udemy and like feeling pretty good and like solving problems, and then today I'm like, I'm just gonna see if I can like spawn something and move it with my keyboard, and I'm like, I just feel so fucked. I'm like,
Don't worry, it gets worse.
Much.
it's just like I'm having issues right now, man. It's because in the game it was like I had somewhere to look at, which I was able to set a direction for stuff, and now I'm like, I just want something to move forward and rotate along its axis, and it just keeps going off in its own direction, and I don't know, I'm about to give up for the day, I think. It's like literally the simplest thing. I was so confident I'd be able to just like make this happen and have this thing moving within an hour. It's been like 2.5 hours.
That's game development for you. Don't despair, though. It's
Part of the process.
part of the
If
process.
it makes you feel
yeah.
better, I got to a point in my game where I was like, all right, I have like, all I have to do is hone in the animation. I'm gonna hire a freelancer to work on the game loop while I do that. It'll be awesome. And then as soon as I did that, my version control fell apart. And while I was paying a freelancer, I had no version control really that was reliable. And I was troubleshooting that for the last 3 weeks.
Oh, that sucks. I'm sorry.
What are you using for your version control?
Perforce.
Oh yeah.
It's, I think, mostly resolved now. Although my game won't package, but I think that's a different reason.
Always one problem.
I think it's because my freelancer's fucking around with like the Steam settings and stuff. So it'll package, it'll package, but it gets a fatal error as soon as you try to launch it
Oh, oof.
Oh,
with no context. It's just fatal
I feel
error.
like that's worse.
Fuck you.
Worst.
Click OK.
I remember my first time I was trying to update last company I worked at, trying to update from 4.27 to Unreal 5 for a VR project that we were developing for already 2 years. I never was able to get an update. And like,
Why did they need to update? I would have just kept it at 4.2. That 2 years?
slowly more tech was coming out, and we were doing architectural visualization. So it was kind of vital to be able to keep up with the tech, especially with Unreal 5's deferred rendering on Quest. That's very important to us to be able to have as much like rendering capacity as possible.
Mm-hmm. All right.
Like,
Well,
yeah.
if you need it, you need it.
Yeah, I don't think the company ever did do
By
that
the way,
after I left.
was it, if anybody else is doing VR stuff, I found 2 settings in project settings that were a game changer when it came to deferred rendering and performance.
Yeah.
This might be a game changer for really anything, as long as you're not using Lumen or anything. I can find it really quick.
Motherfucker.
Wait, so your problem right now, sorry, while you're looking at that, your problem right now is that your ball just keeps getting projected, it keeps its velocity after it's destroyed?
Correct.
And wait, did that respawn you with the ball?
Yes. Well, yeah. Basically, it moved me, but yeah.
I
I
found him.
wouldn't call it a respawn. I'm not despawning or destroying the actor.
Oh, you're not. Okay.
I mean, maybe that'd be easier to do. I just feel kind of stupid because you could walk me through this. I feel super retarded because if I destroy the actor, then how can I call a function within that actor to spawn itself if it's destroyed?
You would have something else call it. You wouldn't have it spawn itself. Probably like your goal, maybe, or game state.
Probably a
Not
manager.
yourself.
Yeah, a manager for your game would be a good
Yeah.
actor to have for such a thing.
Yeah, because I think that's what's happening. It's like, well, there's two things I was thinking that was happening. One is that your two actors are all spawning in the same location for your physics actor, which is causing it to get pushed so happily towards
No.
the goal. That was
They're
like,
not colliding with each other right now.
okay. And then yeah, I would say completely destroy the thing, and then just have somebody else spawn it. That would fix your issue.
All right. Let's see.
Because you would have like a game manager to like do all your point scoring and whatnot, right? I assume because it's like round based.
I think the. Oh man, where is that? Scope is blowing up, bro. Game state. Okay. Which? Oh my god.
God damn it! I thought I'd seen the worst of it. I thought it was finally gonna go down. Fucking Montana, it's snowing like a motherfucker again.
Probably the game state we want to spawn it, right?
Yeah, wherever you choose your trigger to restart the match, probably where you want to choose to respawn it.
Oh, is this the Blitzball game?
Yeah.
Oh,
I have
hell
a
yeah.
Steam page up. You want to wishlist it?
I will. Do me a favor, message it to me. I'm on my laptop now, which is not attached to my Steam account, but like I will if you message it to me.
Done. Cheers. I somehow got 25 whole wish lists without telling anyone about it. Maybe Russian robots. I don't know.
Nice.
Anyone got a place for scary sound effects?
What do you mean? Like a place to like find more?
The bathroom?
Yes.
I'm a bundle.
Do you want to make your own?
Yeah, that'd work.
Well, okay, well that's controversial. I don't know if you're making your own, but 11 Labs has a voice to sound effect generator.
Ah, come on. 11 Labs cost money.
It's
Okay,
free
just
for the
make a new email.
first few things.
And also,
Did
I think
you-
it's $5 a month.
I'm not paying for anything.
All right. Well, then you got Free Sound Bible. You got Sound Bible or freesound.org, and that's about the best places you can go for free shit. But you're gonna have to like give people credit. But you know, it's not so crazy. Otherwise, you're gonna want to make shit yourself. In which case, I don't know. You're good at audio.
Where could I make stuff myself?
Where can you make stuff yourself? Like, you know your computer. In front of your computer is going to be a chair. Hopefully, that chair is where you would do it.
Uh-huh.
Well, you know, what if you have a
I'm a-
standing desk?
Yeah, what if my desk makes me have to stand up?
Then you're fucked.
Oh. I found an AI sound generator.
This is my desk. I just posted it.
That is some goofy. That is a funny, scary ambient sound.
Dude, 11 Labs, you can just make a new email. You can generate so many.
I would
There's
not
a
like
website called 15-minute email. Or 10-minute? I can't remember. It basically just gives you an email for like 10 minutes so you can use to sign up for stupid shit.
What? The application did not respond.
I'm back.
Oh, there it goes. You want to hear this very funny ambience AI made me?
Who am I looking at?
That's good. I wouldn't really describe it as ambience. It's more like I noticed something creepy sound, but it's a good sound.
Yeah, it's not even ambience. Oh, it's only 3 seconds long. Female tank operator.
Whoa.
I don't think they're whispering. Static, short electric zap, wee zoom zoom.
That's crazy. Whoa.
That sounded pretty AAA to me.
That's a good Karen sound. That's not bad.
That sounds pretty good. Oh, here it is.
Inspired me. Change all my game sounds.
Is this ambience? I'd say this might count.
Yeah, that might count.
You know, I should like. Oh.
Man, I'm telling you, just make an email. Get your free 11 labs. It's good shit, man. Really good.
I'm just gonna put fiend. Okay, never mind. I can't do that. Ambience.
You know what? That's right. We should all just get like all our assets made by AI. Nothing weird and bad could happen from this.
Oh no.
It's gonna happen whether or not you personally do it. Maybe that makes me evil. I don't know. Xbox is already
I think it's going to happen, but I don't know if it's going to be games that are bought by anyone.
How can I add footsteps to the first-person character? Have a delay with the looping sound.
Holy shit! You're gonna want to look up a tutorial on YouTube, bro.
Current. Then we have
This is some rocket
population speed.
No, I just don't. It's just like it's such a simple thing that it's like you should just look it up.
Yeah. I just don't want to though.
So
Yeah. If you want to make your own sound effects, just use your phone microphone and then download Audacity and then to edit them. That's like the easiest way. I do that all the time, and it's very efficient.
Doesn't Steam have like this whole like thing against AI things in games, or like you
Oh,
have
yeah.
to label if you like use an AI asset or something like that?
Note.
They
I've
do.
never heard of it.
I just saw Black Ops 6 have AI in their loading screens, and no one cared.
Name and
They didn't get
this
removed from
player
Steam.
start.
They're multi-million-dollar.
Right?
Yeah, well, yeah, Steam
Maybe,
is, Steam is probably, or Valve is probably like,
Whenever you hit
they
this
make us a
button,
lot of money,
Make a
so
blind eye.
yeah.
Well, yeah.
little
Okay.
method where we
Yeah, maybe.
Activision gets even more like
now
you know,
what
the tests
node
you
we are
have to
gonna
do
use.
for like consoles and
Moment.
stuff like that to get
See,
your game approved
character
on
walking
consoles.
inside this.
Activision
We
gets
get it.
a lot more attempts
With Z and now return
as
value.
leeway.
Now we want to go
They
forward
definitely do get
for
some favoritism.
input to the world
Yeah, I guess
directions.
that's true.
Hit compile.
Either that or they're battling legalities behind the scene and we don't get to see it.
Nah, they just get a lot of attempts.
It ghosted your videos coming through your mic a little bit.
Oh, sorry.
Thanks. You know, I wonder how good the machine learning deformers and stuff are. Like, people are actually using those things.
Oh, for like
Machine learning what is?
The machine learning deformer.
the ML deformer.
Yeah.
Well,
Yeah.
I'm sure it will get better with time. However good or bad it is now, that's how they are, right?
Yeah.
It just seems like a lot of extra work to me, like to add all that stuff.
Like, you gotta be going for like a super realistic game for that to even be worth it.
Yeah, it might be more for like virtual production and that kind
that's
of
true.
stuff. They have been focusing a lot more on that stuff that makes them money over the game stuff.
Well, yeah, because it isn't even like just Fortnite that's making money anymore. It's like a whole bunch of like Disney bucks coming in.
Yep.
So, you know, they're putting money into the Fortnite modding scene and then the virtual production scene.
There you go.
Good shit.
That was kind of genius for them to do though, like extending your game's lifetime by. That's not really genius, I guess, but like, you know, Fortnite's gonna die someday, but if you leave the modding scene, it's gonna live for a very long time.
I'm surprised it's not dead, if I'm gonna be honest.
Me too, but people still love it. A
Have
lot
you
of
ever
my
played
family
it?
members still play it.
Or have you played it recently?
Who?
Whoever just said I'm surprised people still love it.
Me? No, I haven't. I actually played it a month ago. Or actually, no, I haven't. That's a lie. I played it a couple weeks ago.
Alright, well, I don't play that type of game. But I know my friend Jumbo, who many of you know, he's big into a lot, like basically every type of game. He plays a lot of games. He was a streamer for a while, and he did not want to play Fortnite for the longest time. And then he did, and he was like, holy shit, this game deserves like the hype. So like, I can't vouch for it myself, but like, I believe in Jumbo's opinion, and I don't know, man. He said it's like the best game of its type by very far. So like, I don't know, maybe
Not like, yeah, it's not like I hate it either. Like, it's probably not a game that I would like to play, but a lot of people like it.
Yeah, when it comes to battle royales, Fortnite's definitely like the best. When it comes to like how much stuff's coming out for it, right? They're constantly coming out with new events, like whether it's a seasonal event or it's like a part-time seasonal event. Like one time they had like some Star Wars content that came in partway into an event and lasted partway into the next season. So like they've got a whole lot of content that they're just like cycling in and out. And the thing is that content is there in their backlog for when they want to reintroduce it. The one thing I hate about Fortnite, and this goes for like most season pass games except Marvel Rivals, is it's very predatory with like, hey, you have to play this game a whole lot this season or else you're not going to get all the value out of that money you spent.
What does Marvel Rivals do different?
When you buy the season pass, you have it forever. So you're able to basically go back in time and go back to that season pass that you bought. I think the season pass purchase is limited time, but you keep it. So once you're done with the next season pass, you could come back to this one that you never finished and finish getting its content.
Yeah, that's so annoying because Call of Duty does that too, where it's like, you buy the battle pass or something, and then you don't get all the skins. Like you have to grind to get the skins that you bought. I'm pretty sure. PUBG does that as well.
That's kind of fun, yeah.
Yeah. That's nutty. I don't know why that didn't like offend me when I first heard it, but now I'm offended.
Well, it bugged me a lot because I got into Fortnite when the Spider-Gwen skin came out. And it was halfway through the season, and I really wanted to get all the Spider-Gwen variants.
Yeah.
And I did. But oh my god, I did pretty much nothing but play Fortnite. And then, like, afterwards, the next season happened. And I think it was even a Star Wars skin. And those who know anything about me, I'm a huge, huge fucking Star Wars fan. And I was like, ooh, I'm gonna get the skin. And I got the battle pass. What's cool about Fortnite is, like, they give you more V-Bucks than what you purchased the battle pass for. So it's even more reason to grind it out.
Yeah.
But it got to the point where I'm logging on, not because I wanted to play Fortnite, but because I had to grind out my battle pass. And it just slowly, really not slow, like really quickly became like a chore to play the game. And I was like, I don't enjoy playing a game like this.
Yeah.
And ever since then, I have hated Battle Pass like systems, except for Marvel Rivals. I was really happy with Marvel Rivals.
My brother recently, I know PUBG is still quite popular right now, but my brother got me back into playing it. I used to hate it, and I still do kind of hate it for its predatory practices, but what was it? I've played 60 hours over the past 3 months of this game, and because I haven't bought anything, like, I have only been able to unlock like one or two skins of just constant grinding, and it's just like a t-shirt. And I'm like, bruh, this is ridiculous. You actually have to pay money if you want anything in this game.
Yeah. Is there a website that has a quick road from Bitcoin to V-Bucks? And if not, why haven't we built it? Ethereum, Bitcoin, all of it, straight into V-Bucks. Because that's really what you want at the end of the day, is the V-Bucks, right?
Free V-Bucks download.
Sounds like something that Epic would think about at some point. But, you know, they love their, like, Web3 stuff. They have, like, NFT, like, they support NFT projects being made with Unreal. I think it's all.
I'm glad that died out real fast. That's not like still a thing. That was like a fad for like 2 years.
It's still a thing.
My God.
NFT games?
NFTs in general. Oh, NFT games too. Oh shit! I thought they kind of died out. Well, I heard about them a lot more like last year, or the year before.
There is a company I know that they do NFT stuff. And it sucks because, like, I came across this company. I really wanted to work there. And at first I thought, you know, they were very based because they were like, yeah, we hate using generative AI. I'm like, awesome. And you scroll down, it's like, we believe in NFTs and Web3. I'm like, fuck. The other thing I hate.
Oh, what up, Frith? How you doing, dude? I haven't seen you in a long time.
It's Frith.
Oh, the baby's crying. I'll be back.
Okay, I think I'm gonna hop out and like hardcore focus on my project. Y'all have a good time.
Later.
It's good seeing you again, Toaster.
Hello?
Yo.
Hello?
Hello.
Oh, that's weird.
Come here. Sit.
And now we have some responses for when our input action is fired off. Now, I would like to change the duration for these from... And now we can play test, and the ability... Now, we don't have to just rollers using enhanced input. The page up and page down keys would cycle to so one repeated is good for. Now, we don't have to just rely on print string nodes. I'm going to delete those 3 so we don't have anything hooked up here, and go back and press play and click in the viewport to engage. And I'm going to use a special console command. We can enter console commands by hitting the tilde key on our keyboard. Now this little black text bar pops up, and I can enter the console command show debug, one word, enhanced input, also one word, and if I hit enter, we now see some information at the top left. We see that we're showing debug for BP bot pawn. We can press page up and page down to cycle between targets. So if we had multiple pawns possessed by controllers using enhanced input, the page up and page down keys would cycle to showing information about those objects. Now, we have a number of bits of information here. It even shows my computer name. We have the location and rotation of our pawn. We also see that our pawn is possessed by player controller. That's the class of the player controller possessing the pawn. That's why the cast from controller to player controller was
I gotta go. I'll see
successful.
y'all later.
And we also see enhanced
man.
input
Take care.
values. It shows that we're using the IMC bot input mapping context, and that there's a single action, IA fire, and it has left mouse button and the F key associated with it. Now I'm going to press and hold the left mouse button, and look at this. It shows that it's triggered, and it's also keeping track of how long it's being triggered. I've now held it for 8 seconds and counting, and if I release, now it goes back to 0. So it keeps track of how long we allows us to can while the game. There will command. For back to this lecture, you can take notes on this, and you do that and write. So it's set up just input action IA fire. Now what I'd like to happen is for our bot pawn to fire a blaster beam whenever we press on one of the inputs that we've linked up to this input action. In my case, I've linked up the left mouse button and the F key to IA fire. So whenever I press one of these, I'd like to fire a blaster beam. So that's the goal. And in addition to that, I'd like to see one of the rifles fire a blaster beam, and preferably before I input that. So I'm going to add a new function by clicking add beam, but I'd like fire rifle to and choose as here. What I can set, and I can right click the return value, split the struct pin, now on type flip flop. Just get rid of one of these function calls and hook both A and B up at location and play sound at location. I'm just going to copy these nodes and come back to BP bot pawn here in fire rifle local zip.
Huh?
Oh.
What you say? Nothing.
Nothing.
Welcome back. Now, I'd like one input action for IA fire, which has the value mouse input different. Now, when you drag it onto the folder, you click move here and not copy. We're going to go to input and create a new input action called IA look. Because we have two. And let's open IMC bot and click plus next to mappings to add a second mapping. Open the drop down and choose IA look and expand that. Now I'm going to open Y is moving, but for now we're just going to into event graph, right clicking and searching for IA look, and we want that event, so let's get that. Now this one has an action value that's different than the action value for IA fire. Remember, IA fire has the digital bool type, right? So it returns a boolean when it's triggered, but IA look is vector 2D. Now a vector 2D is very similar to a vector, except instead of XYZ, it only has X and Y. It does not have Z because it's not a three-dimensional vector, it's only a 2D vector. Now it's a structure, and just like hit results, which are structures, we can break it. We can always drag off of a structure type and search for break and break this particular type of structure to trigger every frame as long as our mouse is moving. We can expand that. We can see that we can add triggers and modifiers if we want. But for now, we're just going to leave it as is.
Hello.
And we need to respond to IA look.
Hey, buddy. Been a long time.
Good, how are you doing?
Not too bad. How are you?
Quite good. Decent too bad. Yeah.
I didn't catch that.
I've been quite well. Again, it's been like
right-clicking and
we're doing
setting
change over
action
time.
value.
I am pleased to hear it, buddy.
What have you been up to? What have you been up to? No.
I have been contracting. It paid the bills.
Money is not getting money.
Sorry? Your microphone's really muffled.
Ah, my bad, my bad. It's I got morning mouth and I have a shitty
The
microphone.
action value for IA Fire.
Oh.
Remember, IA Fire.
I
has
just
the
bought
digital
myself a new
bool
microphone
type, right? So it
on
returns
the
a
grounds of
boolean
I
when
can
it's
buy
triggered,
stuff
but IA look
or I can pay
is
the tax man.
vector 2D.
So I
Now,
bought
vector
stuff.
2D is very similar to a vector, except instead of XYZ,
I figured
it
I'll
only
have
has
some
X
toys,
and
thank
Y.
you.
It does not have Z
Thanks for
because
keeping
it's
the
not a
economy going.
three-dimensional vector. It's only a 2D vector. Now it's a structure,
Well, it's
and just like hit results, which
the
are structures,
our
we can
government
break
here
it.
is doing
We
the
can
best
always
to shred
drag
our
off
economy.
of a structure type and search for break and break this particular type
That
of
doesn't narrow
structure.
it down very much.
If we choose break vector 2D, we can access its
I'm in the
contents,
UK.
which just happen to be X
I'm in the
and Y
UK.
values.
I'm about
Now
to
here's
go
how it
visit your
works.
beautiful
As
country
we're
in
moving
a
our
couple
mouse
months.
left
Very
and right,
excited.
we'll
I've never
have a
been.
value for X, which
It was good. Now it's a shithole. It was. I was.
is indicative of how quickly the mouse moves. Intuitively, that would rotate my controller whenever I move my mouse. Why? Because the controller is a great thing for other components. Our confusing arm and our components are designed to add controller, and we have, look at this, 3 functions. Now we know this takes in a value, and this is the, so as our IA look in, input action is triggered, every frame we're going to get a value for X based on how quickly we're moving left and right. So if we hook this up to triggered, and we hook up the X in for the value, we'll be moving our controller. We'll be adding to its yaw. And there are ways to follow the controller's rotation. For one, we can choose our spring arm. In the details panel, we can search for control. And look at this. There's a variable called use pawn control rotation. This is what allows our spring arm to follow it. Let's check that and go back and press play, engage in our viewport, and let's move our mouse left and right. And we can see that we're moving our spring arm, and our camera, being attached to that spring arm, is moving along with it. How about that? That's pretty convenient. Now, our mesh is not moving, so I can rotate around to the front, and I can see it. Let's say I wanted to see those cannons fire straight on. Pretty cool. Now, that's only for the yaw, right? We saw that we can only move our mouse left and right. If we move up and down, nothing happens. Well, that's where that second axis comes in, the y-axis from our
Empower any SMB customer or prospect to instantly create beautiful websites. Your prospect answers a few simple questions from mobile or desktop, and AI takes care of the rest. Populating the canvas with content, images, and captivating page layouts. They can customize it themselves in a branded experience, start to finish. Customers can upgrade to advanced offerings like e-commerce stores and blog functionality. You embed your technology like booking widgets. It's that easy to offer any vertical, beautiful, high-performing websites in seconds. Learn more at duda.co.
Hey, what's up, it's Philip, and let me show you how to easily create moving platforms. For this video we will use a level sequencer. This way we can do all kinds of animations without going too deep into blueprints. If you're interested in how to animate and move objects only with blueprints, you can check out this video. Okay, the first step is to go add one cube. Scale it so it resembles a platform. Make sure to rename it to keep things organized. Now right-click in the content browser and go Cinematics, Level Sequence, and rename it. Double-click to open it. Now we need to add our elevator. Go Track, Actor to Sequencer. Over here choose our elevator mesh. Before we start, go here that says 30 FPS, and under Show Time choose Seconds. Now click this little dot to add a keyframe. And Sequencer will remember the position of our platform. Now move playhead to 2 seconds. And move the platform up. Also add a keyframe to remember this position. Hold the Alt key and click and move to duplicate keyframe. This will create a 1 second pause. And now hold Alt and duplicate first keyframe. This way it will be exactly in the same position, so we can make a seamless looping animation. You can check how it looks. I think it's fine. And now drag and drop the sequencer to the level so it will be available in the world outliner. Go and open the level blueprint. Dock it up. Right click and add the event begin play. Now go back to the outliner and drag the elevator animation to the level blueprint. Drag the pin and select Get Sequence Player. And from it drag and type play. Connect with the event begin play, compile, and if I click play from here you can see our animation. But we need to make it loop. To do that, go to Blueprint, and we need to connect back to the play node, but it says both are on the same node, so we have a nice little trick to add a delay node and connect it to the play start so it can loop. Double click the middle mouse button to add this white dot so you can organize better. Under duration you can change it to 2 seconds. So we can have a nice pause at the bottom of the animation. Hit compile and save, and you can see your moving platform. I hope you learned something new and useful from this video. If you like this tutorial, feel free to check out my other tutorials about Unreal Engine 5. Thanks for watching and bye bye.
I took 2 things that I love, dancing and dogs, and I made them into a successful business. Hi, I'm Ronnie. I'm the owner of Ketatov, and I teach people all over the world how to dance with their dogs on my website. I was searching for a platform where I can really manage my business, a place that can help me share my knowledge and create a community around dog dance, and I found that in weeks. I have 4 dogs, Bailey, Pesach, Marta, and Rhythm. Rhythm is a dancer. I'm so passionate about dogs, and dog dance. It's the most amazing sport in the world. You're learning to communicate in a whole different level with your dog. As soon as I posted, now I'm opening an online course website, immediately people responded. They started registering, they started asking questions about it, and at this point of time, the online courses are the main part of the business. I have clients from Japan and Canada and the US and Europe and like all over the world. The fact that in such a short time I was able to build my own business, reach so many people around the world, and create such an echo about dog dance, that's something that makes me super proud.